Welcome to today's lesson on performance metrics, a crucial part of evaluating machine learning models. Let's start by understanding why metrics are so important and what they really tell us. Imagine you're training a machine learning model to detect spam emails. You've spent hours tweaking the algorithm and fine-tuning the data. Now, you need a way to judge how well your model is performing. That's where performance metrics come in. They are the tools we use to measure success. Now, here's something to keep in mind right from the start: no single metric tells the full story. In machine learning, the goal isn't always to aim for the highest accuracy or the lowest error rate. The key is to choose the right metric that fits your specific problem. For example, if you're building a model to predict diseases, it might be more important to catch as many true cases as possible, even if it means occasionally flagging a healthy person as at risk. On the other hand, if you're designing a spam detector, you might care more about avoiding false alarms, because no one likes important emails being sent to the spam folder. These different priorities are why we need to understand multiple metrics. Let's dive into some of the most common metrics, starting with *** prediction accuracy ***. Accuracy is perhaps the simplest and most intuitive metric. It measures the percentage of predictions your model got right. For example, if your model made 100 predictions and 90 of them were correct, your accuracy would be 90%. It's easy to calculate, and it gives you a quick sense of whether the model is on the right track. But here's the catch: accuracy doesn't always give you the full picture. Let me explain with an example. Imagine you're building a model to predict whether patients have a rare disease. Only 1% of the patients in your dataset actually have the disease. If your model predicts no disease for everyone, it will still be correct 99% of the time. Sounds great, right? Well, not really. The model isn't actually doing anything useful, it's just ignoring the rare cases entirely. This is why accuracy, while helpful in some cases, isn't always the best metric to rely on. We need other metrics to give us a clearer view of what's happening, especially when dealing with imbalanced datasets like this one. Next, let's talk about the *** error rate ***, which is closely related to accuracy. If accuracy tells you how many predictions were correct, the error rate tells you how many were wrong. It's essentially the flip side of accuracy. If your accuracy is 90%, your error rate is 10%. The formula is simple: error rate equals 1 minus accuracy. While accuracy focuses on success, the error rate focuses on mistakes. This can sometimes give you a better sense of how much room there is for improvement. But just like accuracy, the error rate alone doesn't always give you enough detail to fully understand your model's performance. Now that we've covered the basics of accuracy and error rate, let's move on to metrics that dive deeper into the details, starting with *** precision ***. Precision focuses on the positive predictions your model makes, specifically, how many of those predictions are actually correct. In other words, precision tells you, when the model says something is positive, how often is it right? Think back to our spam detector example. If your model predicts that 100 emails are spam but only 80 of them actually are, the precision is 80%. High precision means your model doesn't make many false alarms, which is especially important in scenarios where false positives can be problematic. But precision isn't the only thing we care about. Sometimes, it's more important to make sure we're catching as many true cases as possible, even if we occasionally make a mistake. This brings us to *** recall ***, another key metric. Recall measures how many of the actual positives your model successfully identified. To put it simply, recall answers the question: out of all the things that were truly positive, how many did the model catch? For example, if there are 100 spam emails in your inbox and the model correctly flags 90 of them, the recall is 90%. High recall is crucial in situations where missing positives can have serious consequences, like identifying diseases or detecting fraud. Precision and recall are often used together because they balance different aspects of performance. High precision means fewer false positives, while high recall means fewer false negatives. But here's the challenge: improving one can sometimes hurt the other. For example, if your model becomes overly cautious and only predicts spam when it's absolutely sure, your precision might go up, but but your recall could suffer because you're missing some spam emails. This trade-off is why it's important to consider both metrics, especially when choosing the right balance for your specific application. Finally, we come to the **F1 score **, which is a way of combining precision and recall into a single metric. The F1 score is the harmonic mean of precision and recall, which might sound complicated, but the idea is simple: it gives equal weight to both precision and recall, providing a balanced measure of your model's performance. If either precision or recall is very low, the F1 score will also be low, which makes it a useful metric for understanding trade-offs. For example, if your spam detector has high precision but low recall, the F1 score will reflect that imbalance, helping you identify areas for improvement. So far, we've introduced accuracy, error rate, precision, recall, and the F1 score. These metrics each provide a different perspective on your model's performance, and the key is knowing when to use which one. For instance, if you're working on a balanced dataset with no particular emphasis on false positives or false negatives, accuracy might be a good choice. But if your dataset is imbalanced or you care more about one type of error than the other, you'll need to rely on precision, recall, or the F1 score to guide your evaluation. To wrap up this part of the lesson, let's remember the big picture. Metrics are tools, and just like any tool, their value depends on how you use them. A great model isn't one that simply maximizes accuracy, it's one that meets the specific goals of your problem. As we move forward, we'll look at examples and practice calculating these metrics to reinforce what we've learned. Now that we've covered the key concepts, it's time to put this knowledge into practice. Let's walk through an example together to see how these metrics work in a real scenario. Imagine you've built a model to classify whether an email is spam or not. To evaluate the model, you've created a test set, and the results are summarized in a confusion matrix. Here's what the matrix looks like. There are 50 emails that were correctly classified as spam, 10 spam emails that were incorrectly classified as not spam, 5 non-spam emails that were wrongly classified as spam, and 35 emails that were correctly classified as not spam. From this information, we can calculate all the metrics we've discussed. First, let's calculate the accuracy. Remember, accuracy is the ratio of all correct predictions to the total number of predictions. In this case, we add up the correct predictions, 50 spam emails and 35 non-spam emails, which gives us 85. The total number of predictions is 100, so the accuracy is 85 divided by 100, or 85%. That means the model is correct 85% of the time. Now let's look at the error rate. As we discussed earlier, the error rate is the percentage of incorrect predictions. Since the accuracy is 85%, the error rate is simply 1 minus 0.85, which equals 15%. This tells us that the model is wrong 15% of the time. Next, let's calculate precision, which focuses on how many of the emails predicted as spam were actually spam. In this case, the model predicted 50 spam emails correctly and made 5 incorrect predictions, where it said non-spam emails were spam. So, the total number of predicted spam emails is 50 plus 5, which equals 55. Precision is the number of true positives divided by the total predicted positives, so it's 50 divided by 55. That gives us approximately 91%. This high precision means the model is very good at avoiding false alarms when it predicts spam. Now, let's move on to recall, which measures how many of the actual spam emails the model successfully identified. Out of the 60 spam emails in the dataset, the model correctly identified 50 but missed 10. Recall is the number of true positives divided by the total actual positives, so it's 50 divided by 60. That gives us approximately 83%. This means the model is catching most of the spam emails, but it still misses a few. Finally, let's calculate the F1 score, which combines precision and recall into a single metric. The formula for the F1 score is 2 times the product of precision and recall, divided by the sum of precision and recall. Plugging in our values, precision is 0.91 and recall is 0.83. Multiplying them together gives us 0.755. Adding precision and recall gives us 1.74. Dividing 0.755 by 1.74 and multiplying by 2 gives us an F1 score of approximately 0.87. This balanced score shows that the model performs well in terms of both precision and recall. As we walk through these calculations, notice how each metric tells us something slightly different about the model's performance. Accuracy and error rate give us an overall view, but precision, recall, and the F1 score provide deeper insights, especially when we need to understand the trade-offs between false positives and false negatives. To wrap up the lesson, let's quickly review what we've learned. Performance metrics are essential for evaluating machine learning models, but the key is to choose the right metric for the task. Accuracy and error rate are good for getting a general sense of performance, but they may not tell the full story when the data is imbalanced or when different types of errors have different consequences. Precision helps us understand how reliable our positive predictions are, recall tells us how many actual positives we're catching, and the F1 score gives us a way to balance precision and recall. Before we finish, here's a final thought to keep in mind. Machine learning isn't just about building models, it's about building the right models for the right problems. Choosing the right metric is an important part of that process. When you work on real-world projects, always think about what kind of mistakes matter most and which metric reflects success for your specific goals. If you can identify the right metric and interpret it correctly, you'll have a powerful tool for guiding your model development and making informed decisions. That concludes today's lesson. Remember, practice is key, so take some time to apply these metrics to different examples. This will help you gain confidence in choosing and calculating the metrics that matter most for your projects. Thank you for joining.